Assalamualaikum and hi to everyone. My name is Nur Kuzairi bin Bacho, matrix number E23G3077 from Department of Geoscience, Faculty of Earth Science, University Malaysia Kelantan. Today, I've been presenting my mini project portfolio titled GeoHazard Mapping and Analysis of Landslides in FRASER Hill, Pahang. Now, we continue to introduction. So, for background of study, Fraser Hill is a well-known highland area, but it also face serious landslide risk due to its steep slopes, complex geology, and heavy rainfall. Many of these landslides are dormant, which means they are not currently active but can reactive suddenly. Unfortunately, most assessments focus only on active slides and ignore dormant zones. That's why it's crucial to study this hidden hazard to ensure safer development and land use. Next is problem statement. There's a major gap in current landslide assessment in Fraser Hill. By focusing only on visible or active landslide, we risk missing dangerous zones that may reactive after heavy rainfall or due to development. This study aims to uncover and map those overlooked risks. Next is my objective. This study has three main objectives. First, to identify and map distribution of landslides in Fraser Hill using integrated geological and geophysical methods. Next, to analyze the geological and geomorphological factors contributing to the formation and reactivation potential of these landslides. Last is to assess the implication of this geohazard on current and future land use planning in Fraser Hill area. Next is significance of study. This research help, helps improve slope safety by identifying high-risk areas and guiding better land use decision. It also contributes to long-term sustainability, infrastructure protection, and environmental conservation. Next is scope of study. I applied a combination of methods, which is topographic analysis, fieldwork, petrographic analysis, and geoelectrical resistivity surveys. I also analyzed historical records, satellite image, and rainfall patterns to understand landslide trigger. For my study area, Fraser Hill is located along the Titiwangsa Range at elevation of 102,000 to 105,500 meters, where it's known for its cool climate. The area's weathered granite, steep slopes, and residual soils make it highly landslide prone, especially with ongoing development. Now, we move on to my literature review. First is geological setting and landslide susceptibility. The geology here consists mostly of schist and granite from the Bentong Group and Central Belt. Fractures, faults, and weathering increase the risk of slopes failure. Geological mapping helps identify which slopes are most vulnerable. Next is importance of integrated geological and geophysical mapping. Studies show that combining geological mapping, satellite imagery, and geophysical surveys give a more accurate picture of landslide risk. This approach helps detect subsurface anomalies like water settled zones or fault lines that might trigger landslides. Next is landslide triggering factors. The most common trigger here is heavy rainfall, especially during the monsoon season. Other factors include weak soils, steep slopes, rock structure, and human activities. When water seeps into the soil and rock, it reduces slope strength and reactivates dormant landslides. Next is importance of landslide susceptibility mapping. We use GIS tools like ArcGIS and the weightage overlay method to classify landslide risk into low, moderate, and high zones. This helps in identifying areas that need slope reinforcement or restricted development. Last is implication assessment for land use planning. Many high-rise landslide zones overlap with residential or tourism areas. If we don't integrate landslides map into planning, we risk building in dangerous areas. This study recommends zoning regulation, continuous monitoring, and using geohazard data in future development plans. Next is methodology. There are three main methodology that I use, which is field mapping. I began by collecting geological and slope data in the field. This includes taking GPS coordinates, photographing scarps and cracks, measuring slope angle, sampling rock and soil. We also map geological structure to understand slot failure. Next is geoelectrical resistivity method. I use geoelectrical resistivity imaging with Schlumberger and deep dipole-dipole configuration. This method detects subsurface features like bedrock, weather root zone, faults, and water-saturated layer. We process the data using REST-2D INV software to produce resistivity profiles of the subsurface. Next is remote sensing. Remote sensing technique like INSAR and digital elevation models (DEMs) we use to track slope movement. All data sets were integrated in ArcGIS to generate the final landslide susceptibility map. So this is the research flowchart showing how my study was conducted step by step. First, we start by determine study area. Next, we go to data collection like my methodology. And then after that, we process the data and we know the hazard identification. Last is we produce risk mapping and zonation. So last is writing report and presentation. This is my Gantt chart and milestone. Each task like fieldwork, lab work, and mapping is assigned to specific weeks or months. This helps to track my progress and manage time efficiently. This is my milestone. Milestone is key checkpoints like completing field surveys or generating final maps. Reaching each milestone ensure that project stay on track and is complete within deadline. Next is my research budget. For my project, so this is all the research budget that I use. Lastly, these are the key references that supported my research. They include study on landslide susceptibility, mapping using GIS and remote sensing techniques, as well as geophysical methods such as geoelectrical resistivity profiling. These references provided a strong foundation for integrating multidisciplinary methods in my project. That's all from me. Thank you.